Okay, today we move on to another topic, and that is dispersion, right? That is dispersion of white light. Dispersion of white light by a glass prism. Dispersion of white light by a glass prism. Here, I'm on actually page number 203, right? Page number 203. So we will discuss about dispersion of white light through a glass prism. Now let us assume that this is a glass prism, okay? Or when a white light, okay, when a white light hits this glass prism, what will happen? Here we need to understand, when I'm talking about this white light, it's a natural source of light, okay? We are not talking about any artificial source of light. White light. So by white light we are normally talking about the natural source of light, and you know that the natural source of light is that given by the sun or the sunlight. Okay, now when this ray of light, okay, when this ray of light, that is a white light, travels, now you have to go back to the chapter of refraction. Here this is air, okay, this is air, and this is what? This is glass, right? So air over here is your rarer medium, and glass over here is your denser medium, right? So we need to understand that this ray of light is traveling from a rarer medium into a denser medium. So when a ray of light travels from a rarer into a denser medium, it bends towards the normal. You will have to recollect the fact that when a ray of light is traveling from one medium into another, refraction takes place. That means the ray of light will bend. Okay, let us suppose that this ray of light, okay, this ray of light enters the glass and it bends, right? There will be a bending. Now this bending, okay, as the ray of light enters into the glass, refraction will take place and this ray of light will bend. But for strangely, it is not that only the bending takes place. There is something else happening in it, right? And what is happening? This single ray of white light, okay, this white light bends and then splits into how many colors? It splits into, let's say, 3, 4, 5, okay, 6, 7. It actually splits into 7 color, right? And what is that 7? V, I, B, G, Y, O, R. So there is something very strange happening to the white light when it passes through the glass prism. As the ray of light passes from air into the glass, right, that is, as it passes from a rarer into a denser medium, definitely refraction takes place. But added to that refraction, what happens also is this single ray of light is split into 7 colors. Now if you look on page number 203 in your textbook and you read, you will find the prism has probably split the incident white light into a band of colors. Note the colors that appear at the two ends of the color band. What is the sequence of color? What do you see on the screen? The various colors seen are violet, okay, so you see violet, indigo, blue, green, yellow, orange and red. The acronym is VIBGYOR, VIBGYOR, will help you to remember the sequence of colors. So if you want to know what are the different colors that is formed by the splitting of one single white light, you will find that there are 7 colors. An easy way to remember is the acronym VIBGYOR, VIBGYOR, okay. The band of color components of light beam is called its spectrum. The band, okay, the band. The band of these 7 colors is called as spectrum. You might not be able to see all the colors separately, yet something makes each color distinct from the other. The splitting of light into its component color is called as dispersion. So, dispersion, right? What is dispersion? The phenomenon, okay, dispersion, 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 right? What do you understand by dispersion? The phenomenon by which a single white light is split into how much? It's split into its 7 components, the splitting of white light into 7 colors. The simple definition will be the phenomenon of splitting the white light, single white light into its seven color is what we call it as dispersion, right? all the all the colors together, the band of seven colors is called as spectrum, and the splitting of white light into its seven constituent colors is called as dispersion. Now continuing further in reading, you have seen that white light is dispersed into its seven color components by a prism. Why do we get these colors? Different colors of light bend through different angles with respect to the incident ray as they pass through the prism. Now, another very important thing to keep in mind is all the rays of light do not bend at the same angle. You see, wave gear bends the most, okay? Wave gear is the one at the bottom, so it is this which bends the most, and red is there on top, okay? Red is there on top, and therefore red is the one which bends the least. So you have to understand that the colored light, okay, the colored light which bends the most is what? The one bending the most is violet, okay? The one that bends the most is violet, and the one that bends the least is what? The one that bends the least is red, okay? Okay, the red light bends the least while the violet the most. Thus, the rays of each color emerge along different paths and thus become distinct. All Since the rays of light are bending at different angles, so you are able to see the colors very distinctly. Okay, so uh, in short, once again, what is dispersion? When a ray of light, okay, when a ray of light passes through a glass prism, it undergoes refraction, and because of which it split into its seven constituent color. The phenomenon by which the white light splits into its seven constituent color is called as dispersion. Different colored light bends at different angle, and so which colored light bends the most? The one that bends the most is violet, and the one that bends the least is red. Okay, this is what we have to remember. Moving further down, Isaac Newton was the first to use a glass prism to obtain the spectrum of light. He tried to split the colors of the spectrum of white light further by using another similar prism. However, he could not get any more colors. He then placed a second identical prism in an inverted position with respect to the first prism, right? Now, carrying the study forward, Sir Isaac Newton, he did something else. Okay, he also wanted to study what happens. Okay, it is very clear. He found out that when there is one prism, okay, when we take one prism and allow the white light to pass through this prism, it splits into seven constituent color called as dispersion. Now Isaac Newton wanted to find out what happens if you have two identical prism one placed inverted to the other. So we have one prism in the erect position here and the another prism in the inverted position here, right? So when he allowed, right? Now you need to understand this. When he allowed a ray of light to pass through the first prism, right? It underwent refraction, okay? It underwent refraction and split into how many colors? It split into seven colors, right? And when these seven colors were allowed to once again pass through the inverted prism, surprisingly, what he found was the color, ultimately what came out of the prism was a single white light, right? Once again, let me explain this. When Isaac Newton, he tried to do an experiment with a single glass prism, what did he found? He found that when a natural white light, okay, when a natural white light is allowed to pass through a glass prism, right, that ray of light splits into what? That ray of light splits into seven colors, as I had told you earlier, and those seven colors were can be remembered by the acronym WAVEGIO, right? But if this seven colored light, okay, if this seven colored light were allowed to pass through another inverted prism, what was the final result? The final result was all these seven colored light once again combined together to give you a single white light, right? Single white light. So you have one single white light. This is dispersion, splits into seven, right? Now all these seven combined together and again comes out as a single white light. So what did he found? He found a beam of light, white light, emerging from the other side of the second prism. In the first prism, it is seven colors, but in the second prism, he found that there is a beam of white light which comes out, right? This observation gave Newton the idea that sunlight is made up of seven colors. So this experiment, right? This experiment conducted by Newton, okay? What was the experiment? The experiment was he took two glass prisms and placed one inverted to the other. When he allowed a ray of white light to pass through the first prism is split into seven. Now when he allowed the seven colored light to pass through the second inverted prism, it came out as a white. It came out as a single white light, beam of single white light. Remember, this seven white light is actually made up of seven colors, right? But when it comes out as a white. Now from this experiment, okay, conducted by Newton, he concluded that sunlight, okay, he concluded what? He concluded that sunlight is made up of what? Sunlight is made up of seven colors. A very important thing to remember. So the question can be, what was the experiment done, right? Or how was the experiment done to prove that sunlight is made up of seven colors? So this is the experiment, okay? Then any light that gives a spectrum similar to that of sunlight is often referred to as white light. So what do you understand by that statement? Any light that gives a spectrum similar to that of sunlight is often referred to as white light. That means, other than sunlight, if there is any other colored light which on refraction produces seven colored lights, now that will be similar to what? That will be similar to that of the light produced by the sun, and it can be considered as a white light, right? The natural white light. Okay. Basing what is the natural phenomenon that takes place, okay, that takes place basing on this particular experiment. And the best example for this is what? The best example for this, uh, the best example to show the splitting of a white light into seven colors is the rainbow. You know that rainbow is formed in the sky after a rain. And very important, you also need to know that rainbow is always formed in the sky after the rain opposite to the sun. Okay, the rainbow will always be opposite in the sky. The rainbow will always be opposite to the sun. Okay, let us read. A rainbow is a natural spectrum appearing in the sky after a rain shower. It is caused by dispersion of sunlight by tiny water droplets. So just now I told you that if you have a glass prism, right, and you allow the natural white light, it splits. But in the atmosphere there is no prism, right? So what acts as a prism to split the sunlight? It is actually what? It is actually the raindrops, right? Each raindrop acts as what? Each raindrop acts as a prism, right? And so when the white light passes through this raindrop, it undergoes refraction and splits into what? And splits the light into its seven constituent colors, right? Seven constituent colors. So then we can say that the raindrop acts as a natural prism, right? Then a rainbow is always formed in the direction opposite to that of the sun. The water droplets act like small prism. They refract and disperse the incident sunlight. They reflect it internally and finally refract it again when it comes out of the raindrop. Due to the dispersion of light and internal reflection, different colors reach the observer's eye. So in the formation of the rainbow, right, in the formation of the rainbow, what are the two things taking place? Please keep in mind the two things which takes place, or the two things because of which we see the different colored light in the form of a rainbow is, one is dispersion of light, okay, one is dispersion of light, and the other one is total internal reflection. Please keep in mind total internal reflection. So what are the two phenomena that help in the formation of the rainbow? And the answer to that question is, one is dispersion of light and the other one is total internal reflection. You can also see a rainbow on a sunny day when you look at the sky through a waterfall or through a water fountain with the sun behind you, right? So a very small and simple topic we have discussed about what is dispersion of light, what is spectrum, and how rainbow is formed in the sky. What helps in the formation of rainbow? And the answer to that question is the water droplets that remain suspended in the atmosphere after the rain.